Hello friends, welcome to the new video. In the previous video we have discussed about augmented matrix and how to write a system of linear equations in form of matrix, and some how to solve a system of linear equations using augmented matrix. Solving system of linear equation we have learned already, and now in this video we will discuss some type of question that are asked related to this topic. So here I have taken a question that is written here. A matrix is given. In this question here it is given that if a system of linear equation is represented in the form of matrix here, if the system is consistent, find an equation for which G, H, K must satisfy. And here G and H and K, three values are unknown here, and we have to find the relation between G, H and K for which the system is consistent. Let's see how can we do it. And first what we can do, we can try to solve the system of linear equation. We can try to solve this system using row operation that we done already. What we have to do, we have to make these three values we have to convert into 0. So to convert here -2, what we have to do, first if we do this -2 as into 0, then to convert this -2 into 0, what we can do, if we multiply row 1 by 2 and if we add it in row 3, this -2 becomes 0. How? If we multiply row 1 by 2, it becomes here, this position becomes 2, and if add -2 and 2, it becomes 0. So I have done that here. Here R3, that is row 3, I have applied row operation in row 3, and what I have done here, I have add R3 plus 2R1. I have multiplied R1 by 2 and added it to R3. Let's see what it will give. If we multiply R1 by 2, it will give 2 minus 8 14 2G. -2 plus 2 0, 5 minus 8 minus 3, and -9 plus 14, it gives me 5 here, and 2G plus K, it gives me here 2G plus K. Now what I have to do, since I have this point already 0, now I have to convert this point 0, and now here this point is already -3, so I have to convert it to 0. So if we add row 2 to row 3, 3 minus 3 cancel out and it becomes 0. So after adding row 3 to row 2, we get this position, -3, 0 plus 0, that is 0, -3 plus 3, that is 0, 5 minus 5, that is 0, and here 2G plus K plus H, and it gives 2G plus H plus K. So from here what we get, 2G plus H plus K is equal to 0. So it is given that the system is consistent. So if we have this system of linear equation consistent, so it is necessary that this must be 0. If it is not equal to 0, then what becomes, if this term 2G plus H plus K will not be equal to 0, then it becomes 0 is not equal to some value not equal to 0, because not let 2G plus HK plus not equal to 0, let it m. 0 is not equal to m, where m is not equal to 0, then it becomes, here it becomes 0 is equal to m, that is m is any not non-zero value. So that is not possible. So 2g plus h plus k must be equal to 0. I hope you have understood this. I mean to say that if 2g plus h plus k is not equal to 0, it will give 0 is not equal to some value that is not equal to 0, which is not possible. So 2g plus h plus k must be equal to 0, and that is the relation between this system of linear equation to be consistent. So that is the relation between g, h and k. So we have the next question here, that is, do the three planes, equation of three planes is given: x1 plus 2 x2 plus x3 is equal to 4, x2 minus x3 is equal to 1, and x1 plus 3 x2 is equal to 0, have at least one common point of intersection. We have to find the equation of three plane is already given, and we have to find that is there any common point of intersection between these three planes. I will discuss some topics of plane here, some general information about it. If two planes are intersecting, let's say, then what will we get at the intersection point? If two planes are intersecting, we know that if two planes are intersecting, we get a line. But if three planes are intersecting, what is the possible condition that can happen? If three points plane are intersecting, it means we will get a point. How? Let a plane A, B, C, three planes, A and B give one line, B and C give one line, and if two lines are intersecting, we get a point. So I hope that you understand. If two planes are intersecting, it means we get a line, and if three planes are intersecting, it means we get a point. Now we'll discuss what are the possible conditions if three planes are intersecting. Let's see. If three planes are intersecting, it means if we have three system of linear equation with three equations. See, if there are let's say we have three planes, x1 plus x2 plus x3 is equal to 0. Let's say that I am taking example x2 plus x3 is equal to 5, and x1 plus x3 is equal to 7. In this situation, we are getting three system of linear equation that are the equation of a plane of three planes. So if we are solving these three equations using augmented matrix, there are three possible cases: no solution, or unique solution, or infinitely many solutions. So here we'll discuss these three conditions or cases, that if we are getting these three cases, then what it mean in the case of plane. Let's see. If there are no solution of system of linear equation, it means there is no common point of intersection in three planes. If we are getting unique solution, then it means there is a unique intersection point of three planes. And if we are getting infinite solution, it means there are infinitely many common intersection points. So I think it is clear that if you are getting no solution, there is no intersection point. If you are getting unique solution, it means there is one unique intersection point. If we are getting infinity solution, there is infinitely many common intersection points. Now we have given equation of plane, that is in the question, that given question is x1 plus 2 x2 plus x3 is equal to 4, x2 minus x3 is equal to 1, and x1 plus 3 x2 is equal to 0. Now we write it in form of augmented matrix. In the first equation, the coefficient of x1 is 1, coefficient of x2 is 2, coefficient of x3 is 1, and the constant is 4. In the second equation, similarly, x1 coefficient is 0, x2 coefficient is 1, x3 coefficient is minus 1, the constant is 1. And similarly, in third equation, the coefficient of x1 is 1, coefficient of x2 is 3, coefficient of x3 is 0, and constant is 0 here. Now what we have to do for solving the system of linear equation, what we have to do? We have to convert these 3 points into 0 using row operations. What will row operations use here and convert these 3 points as 0. So first we'll try to make, this is already 0, so we have to make this one 0. What we can see, if you subtract row 1 from row 3, this one will convert to 0. So this is this I have done here, r3 minus r1. That means I am subtracting row 1 from r3. 1 minus 1, that is 0. 3 minus 2, that is 1. 0 minus 1, that is minus 1. And 0 minus 4, that is minus 4. Now I have to make this point, that is 3, that is here. After applying row operation first, we get 1. Now we have to convert this one as into 0. Now if we subtract r2 from r3, this one will convert into 0. So after applying this row operation, we get 0 minus 0 0, 1 minus 1 0, minus 1 minus minus 1, that is 0, minus 4 minus 1 minus 5. So here what we get, 0 is equal to minus 5. That is not possible. So the system is inconsistent here. Since 0 is here, 0 is equal to minus 5, so this system is inconsistent. So there is no solution. It means there is no solution of this system of linear equation. So there is no common point of intersection of these three planes. So now we will discuss Echelon form of a matrix. What is Echelon form of a matrix? So before discussing that, let's discuss some point that is called pivot. What is pivot called? In every row operation, you will use pivot to create 0. So we have to in row operation also we have to create zeros at some points, and that is, in this case we have to create 0 at here 3 points, these 3 points, these 2 points, and this point. We have to create their 0. I have also mentioned it here. We have to create 0 here, here, and here. And other than this, these all also point can be 0, or otherwise these points these can be 0 or any other value, but these values must be 0. These places must be equal to 0, and other than this, these places can be 0 or what, anything, any value they can be, but these values must be equal to 0. So this is called the Echelon form of a matrix. So we are discussing pivot. What is pivot? Pivot is a in every row operation we use any number. That in this, if I want to make here minus 1, I can use a number here from here to make it 0. So pivot is nothing on place or number that we use to create any at any place 0. And a note is written here that Echelon form of matrix is nothing but another matrix of same dimension. So the dimension of Echelon form is same. You can see from here that we are nothing changing in dimension of matrix. We are only converting some of the places into 0, that is these places to 0. So that does not changes the matrix dimension. Now we will discuss using an example that how we can convert any matrix into row echelon form. So I have taken example here. Let's take this example, that is the same question we have written above. So now we'll take in this example to solve here. This is the same example. So first we can see that if this point is 0, we can't make this minus 1 to 0 using this 0. If we multiply any number in 0, it will be always 0, and adding 0 in minus 1 will not give us will not be able to make this point 0. So what can we do? If we exchange row 2 with row 1, then it is possible to make this point 0. So that we will do here. I have applied here row 1 to R2. I have interchanged row 1 with R2. It will give me that 0 will this row will come here and this will row go here. So I have interchanged row 1 with R2 and it gives me this. Now what we have here, we have minus 1, and so if I want to make this point 0, this is already 0. We are seeing that this is already 0, and now I have to make this point 0. So if we multiply row 1 with 2 and subtract with row 3, it also becomes minus 2, minus 4, minus 2, minus 2, and 6 and 2. And if we subtract minus 2 from minus 2, it will give us me 0, and minus 3 plus 4, it will give me 1, 0, minus 2, yani it will give me 2, 3, minus 6, it will give minus 3, and minus 1 minus 2, it will give me minus 3. Now I have two zeros. At this 2 point I have 0, but here I have 1. So I have to make this point also 0. First I'll try to make this point 0. So I can see here minus 1 by 3. If I multiply this whole row with 1 over 3, this will give here minus 0, minus 1, minus 2, 4 over 3, and 3. And if I add 1 and minus 1, it will give me 0. So what I have done here, R3 plus 1 over 3 of R2, and that gives me here 0, 0, 0, because 2 minus 2 is also 0, 1 minus 1 is 1, minus 1 is also 0, 2 minus 2 is also 0, minus 3 plus 4 over 3 gave me minus 5 over 3, and minus 3 plus it is 3, because 9 over 3 is 3. The minus 3 plus 3 is also 0 here. So now I'll try to make this point 0. So I'll add R4 into R1. So 1 plus minus 1 is equal to 0, 4 minus 2 is 2, 4 minus 1 is 5, so 5 minus 1 will give me 4 here, minus 9 plus 3 give me minus 6 here, minus 7 plus 1 give me here plus 7 is 7, here give me 6 here, minus 7, so minus 7 plus 1 give me minus 6. Now what we will do, in row operation, now I'll do this row operation, that will do R4 plus 2 over 3 R2, and from this we'll get these 3.0 already, these 2.0, and now we'll get these 2 points also 0. So this is now reduced to an echelon form. So this is an echelon form of a matrix. So matrix is in echelon form. Now we'll check, is this in matrix in echelon form of given matrix? Let's verify using a definition of echelon form. Now we'll discuss the definition of echelon form and check whether this matrix we have written here is in echelon form or not. Let's see the definition. The definition of echelon form is a matrix is in echelon form if it has following three properties. What is the three properties? All the non-zero rows are above any rows of all zero. Let's say if a matrix has a zero row, it must be bottom to all non-zero rows. That in this case, it here zero, here we can see that if we have three zeros already here, so on this basis we can't say only that is in echelon form. We it must satisfy this condition also, that all non-zero rows are above any rows of all zero. Here we can see that a row with all terms 0 is above a row with one term non-zero. So what we do, we enter in row 2 with row 3 and we'll get this matrix that is in echelon form, and we get here the non-zero row above a zero row. Now let's discuss the second definition, that says each leading entry of a row is in column to the right of the leading entry of the row above it. What does it mean? Let's see by this example. What is the leading entry? Leading entry is a non-zero entry of any row. Let's say if we have a matrix 1 2 3 4 0 1 2 3 0 0 0 1. So in this matrix, in the first row 1 is leading entry, in second row here this one is leading entry, and this row here this one is in leading entry. So now in this example, let's see what is here. If here we can see that this is leading entry, this is leading entry, this is leading entry, and this is leading entry. So this definition says that every leading entry should be in right to the leading entry of above row. So in the first row leading entry is here, in the second row leading entry is here, so the second row it is in right. So in the third row leading entry is here, so this is in right. So in the fourth row the leading entry is here, so it is in right. So this statement is also satisfying here, so this is in echelon form. So the third condition says the all entries in a column below a leading entries are 0. So this means that we'll see the column of the leading entries. Let's see here 1 2 3 and 4. These 4 columns contains leading entry. So all the entries below the leading entry, so below this, below this, below this, and below there's nothing, must be 0. Say here we can see this, all are 0, all are 0, this is 0. So this condition also must satisfy to for a matrix to be in echelon. So now we'll see the example we have solved above here. Is this in echelon form or not? Let's see. We can see that let's use the first definition. Let's say the first condition is satisfying or not. First condition is that all the non-zero rows are above any rows of all 0. Here is any 0 row? No. If there is not a row with all the terms 0, will not check the first definition. Let's move on to the second definition. The second definition is that all the leading entries must be to right of the leading entries above it. So let's mark the leading entries. Here the leading entry is this, in here the leading entry is this in second row, in third row leading entry is this, and in fourth row leading entry is this. First row leading entry is here, second row it is in right, third row leading entry is in right, but in fourth row we can see it is just below to this. So this condition not satisfying. So we'll try to satisfy this condition. So now let's see how we can use row operation to satisfy that condition. So here it is in not in echelon form, since this is just minus 10 over 3, that is leading entry, is just below to minus 5 over 3, the leading entry above it. So we'll try to convert in row echelon form. So what we do, if we multiply row 3 by 2 and subtract it from row 4, it will become 0 here, and so it will convert in echelon form. So that is I have done here, and let's see, after doing this row operation, we'll get this matrix, and in this matrix we'll check here minus 1, sorry, here it is minus 1, and all the terms are below this minus 1, and leading entry is minus 3, leading entry is minus 5, every leading entry is to the right, and the 0 row is below to the all non-zero rows, and in the leading entries all the elements, all the terms below the leading entry is 0 here, we can see. So this is satisfying all the three conditions to be in echelon form. So this matrix is in echelon form, and also a note is given here that is very important. Echelon form of matrix not unique. So echelon form of any matrix is not unique. If you use any other two operation, you can get any other echelon form, but we'll see in next lecture row reduced echelon form. The reduced echelon form of every matrix is unique. So if you find a reduced echelon form of any matrix, and I find a reduced echelon form of any matrix, we both get same answer. So that's all in this video. Thanks for watching the video. Please like, share and comment if you like the video, and the notes are available in description box, so don't forget to check out, and please share with your friends if you like the video and found it helpful. So thank you for watching the video.